solve by factoring, solve by
I got
graphing,
the 6 and then.
Yeah, we
solve
got
by
that.
doing the square. Completing the square
Negative
and that
2x
next
plus
one.
6x would be
Good
4x.
ideas.
So we write 4x as negative 2x plus 6x.
So
I have a question.
Miss Courtney's teaching. You can ask me after class. You still have it.
Okay, so we're starting on lesson 6, which is starting to talk about imaginary numbers and complex numbers. So remember how we may have briefly talked about in this class before, like if we take the square root of 4, or if we have to solve this equation, how are we going to solve, or I guess, how would we solve this for x?
Take square root.
So that would give us x equals 2. But what would happen if you had in your calculator, if we had to solve this equation, what would happen if you tried to solve for x here? Well, can you take the square root of a negative number?
No.
Do you remember what would happen if you tried to put that in your calculator?
You're not here.
It's that, yeah, it'll give you some type of error, and it's because we can't take the square root of a negative number when we're talking about the real number system, which, as far as you guys have ever worked with types of numbers in math, you've only been working in the real number system. So now we're starting to introduce, like under the complex number system, where like these imaginary numbers come in. For real. Okay, so on this getting started, it shows us the picture of 3 graphs, and it says, look at all the graphs and list the characteristics you know about each function. So we're talking about zeros, x-intercepts, stuff like that. And then B asks you to compare them and ask what they have in common and what's different about them. So let's look at these 3 graphs. So what's the first thing you notice about the numbers of zeros and the x-intercepts?
Oh, they are zero. Oh, no.
So like, well, if we have a graph, why would you want to know what the x-intercepts are previously? Like, why would I want to know what the x-intercepts are from a graph? What does that tell me about that function? Well, they're all quadratic. So what are the x-intercepts? What relationship is there?
Well,
Those are the zeros, but also
way across there.
roots, zeros. Those are our like solutions, because that's what we've been doing. Is we've been solving these quadratics. So remember, all quadratic equations have how many solutions?
3. You ain't like 2, 3. Yeah.
2. Why is it 2, Ryan? Why are they all gonna have 2? Because it's quadratic, right? Because it's square. So this only has one x-intercept, but how many solutions does it have?
2.
Right? Because remember, we call that a double root.
Yeah.
So what about looking at this one? What would the solutions to this quadratic function be? Okay, so 0 and 6, you're looking at where it's crossing that x-axis, right? Well, what about this one? What are the solutions to this one? Does this have solutions?
You got a,
What's up, Cam? But it's quadratic, so we know it has to have 2 solutions, right?
Yeah.
So that's what we're getting at here, where it's not crossing the x-axis, it doesn't have these x-intercepts, and the x-axis represents our real numbers, right? So essentially this means that this quadratic doesn't have real solutions, it's going to have imaginary solutions. So before we move on, let's go ahead and just fill in this. For B, you wanna write that the graphs have a different number of x-intercepts. So remember, we wanted to be able to identify those x-intercepts working the real number system to know what our solutions are. But if we have imaginary solutions, can I look at this graph and tell what they are? Okay, keep that in mind. So going over to 6.1, this graph is the same one we've been looking at from that getting started. So it says, okay, well we can't look at we don't know what the roots are by looking at the graph. Well, what's another way we've been trying to figure out what the roots are?
Table.
Have we used tables to find the roots, guys?
No.
Algebraically, which means we would do what with the equation? Solve it by doing what with it? But before what am I solving x squared plus 1? What's the solve? There's nothing to solve for. I gotta say equal to 0 before I can solve it, right? Okay, so they're saying if we can't do it graphically, let's see what it looks like algebraically. So, this number 1 says, what did Mark do wrong? So let's look at what Mark did. He set it equal to 0, and then what would you guys do first? Okay, subtracting from 1 to create that 0. Okay, is that what he did? Okay, then what would we do next typically? Okay, well we would take the square root. So, but is the square root of -1 plus or minus 1? So what did he do wrong?
But it ain't right.
Well, we can't take the square root of a negative number. Because if we try to, is there anything you can square, or is there a number you can multiply by itself that's going to give you a -1? No, because remember, if you're squaring or taking the square root of something, you have to work backwards as well. It has to go both ways. So, when it's asking what Mark did wrong, we can say you can't take the square root of a negative. Huh? Okay, well then just write number 1 and you start writing.
You need me to make a copy? So you don't have this?
Okay, so we know what Mark did was incorrect because we can't take the square root of a negative number. So look at what Elena did. Okay, which I kind of wish they would have flipped these. Put Mark's first. But look what Elena did. So she subtracted that negative, or I'm sorry, she subtracted her 1 and got to the same place that Mark did, and then when she took her square roots of both sides, she just left it like this. You see what I'm talking about? So that's her solution. Does that square root of -1 fall within the real number system? Can you tell me why, Jayla?
But you don't have a solution.
Well, remember, right, because it doesn't, we want to say that there's no number you can multiply by itself that's going to give you that -1. So that's why we're trying to explain, because it's all, which you'll see on the next thing. This is where we start talking about like the imaginary numbers.
Yeah.
So for this we can write,
We're gonna be I need 1 from.
yeah, that I is about to come up. We're about to see what all that means. But for this part, we'll just say no.
Seven.
Seven?
Good enough. Yeah.
Did we get
If
explained?
it would have, yeah.
So y'all remember. Okay, okay. Okay, so it's not in the real number system. Well, then on this next page, oh wait. So this is where we're getting this, introducing the number I. Okay, listen to what I'm saying. The number I.
The number
I know, the number I.
That's what that I is.
Not like infinity. So read this. It says the number I. Think of it similar to the number pi. How do you got when you hear pi? What do you think about? Like you associate it with some value. Like you're giving it a number, right? You're saying when you say pi, you're meaning some number, right? Okay, I is a number. I don't know what number it is, but it's a number.
Any number?
But it's not a variable. We can't substitute. It's not like x where we can substitute things in for it. It doesn't change, right? It's just a number. So they're just special. They get their own symbol. So this part is just explaining that we're bringing in this imaginary number to help us calculate the square roots of negative numbers. So there must be a number such that when it's squared, it's equal to a negative number. For this reason, mathematicians defined the number I. The number I is a number such that it is defined as I squared equals -1. Highlight that, circle it. You need to know that. I squared equals -1. I squared equals -1. What does I squared equal? Never forget it.
So I is a negative.
Well, let's see what I is. So that's our next thing. Is if I squared is -1,
That means I got a negative value. Like,
if I squared is -1, then what is just I?
I gotta be negative
One.
one too. So don't
Well, remember to be able to
One.
When you square something, it's multiplying by itself.
right, because remember you have to do that reverse process and get that number. So what would I be?
Nothing.
Can't be nothing. It's gotta be something.
Why is it not -1?
Well, I squared is -1. So
You got a motion. If it was positive, then.
So how can I what's the inverse of the squaring something? So if I want to take the square root of both sides, wouldn't that cancel out my square?
Yeah.
So what am I left with?
I
I equals,
The square root.
-1 squared.
no, hold on, square root of -1.
No,
Okay, does that make sense?
No.
Yes.
So, if I is the square root of -1, what would I squared be?
Oh, -1.
Because remember when you do like, so I times I to equal I squared. Well, if we have this is the square root of -1 times the square root of -1, when you do a square root times a square root,
No,
they
Yeah.
cancel each other out.
So it's still negative.
So that would be the -1. And we know that I squared is equal to -1. Okay?
You can't do it like that.
Y'all see this? Does this help a little bit? If you know that I squared is equal to -1 by definition, you can use that to help you find what I is. Okay? So then we're going to use this idea of the square root of a -1 being represented by I is how we kind of talk about it in the using like the imaginary numbers under that complex number system. Okay, so make sure y'all have this part written under number 3. Like for the value of I, you need to know that the value of I is equal to the square root of -1. Okay, so now that we have a way to find roots that aren't real, or the zeros that aren't real, let's revisit that original function we were given and see if we can find what its roots are in terms of I. So how would we do that? Well, where was my problem the first time? Where was I stuck?
We could find those.
I couldn't take the square root of a negative, but now do we know what happens when we take the square root of a negative?
Yo,
Okay, so let's see what that looks like. Okay, so right where we were last time, we're like, oh shoot, can't take square root of negative. Well, what's that gonna give me? I don't know.
X equals the square root of negative.
Well, what is the square root of -1 equal to?
Aye.
So when I take the square root of something, how many possible solutions do I have?
Two.
So that means that my zeros here would be x equals,
Or square root of
I.
-1.
it's just I.
Yeah,
It's just I. It's just I.
So plus or minus I.
Yes. Because the square root of -1 is I. They're equivalent. Okay? So we're talking about, remember in the real number system, we can't have the square root of negatives. So that is why we have to introduce this imaginary number. Which is not really it exists. It being called imaginary contradicts like how you guys need to see it, but it's real. It's real, but it's not real, but it's imaginary. So,
I ain't never heard no I in my life.
So that's because the
Part
first
of the
time you study it
alphabet.
is in algebra 2.
yeah, so like I was saying, I'll show you, when we look at like how the number system's kind of broken down, I'll show you guys like, look, you've only been working in this real number system pretty much since kindergarten, okay? That's all the math you've ever seen, and now we're introducing this complexity into it. Okay, so but let's look at number 5 and just kind of think about these big ideas that we've come across so far. So, how can you tell from a graph whether or not it has real zeros or imaginary?
Trying to go on get the wrist.
That's it. So remember, it's gonna have solutions regardless. It's gonna have solutions regardless. It's just a matter, are they real or are they imaginary? And that's, how do we know that, Jay?
The thing touches the x-axis.
If the graph crosses, if it has x-intercepts. So, we'll say if a graph has x-intercepts, then, so if it has x-intercepts, what kind of solutions does it have? Khalil's gonna be the only one to answer this. Khalil. Huh? Because whenever I do say somebody's name, everybody thinks so I gotta make sure y'all don't just talk. Okay? So Khalil, if it crosses the x-axis, are those solutions gonna be real or imaginary? Okay? So so 6 asks us, can you determine what the imaginary, so if we looked at this graph, you would say, okay, no real solutions, it's gotta have imaginary. Well, can I look at this graph and tell you what they are? How did we find the imaginary solutions? We had to find those imaginary solutions algebraically, which I think that's all it's saying here. You want a sad face, Ryan? So, Jaden, how do we have to find imaginary solutions? If I can't just look at the graph and figure them out, what am I going to do?
algebraic.
See? And that's why I said his name 8 times, because Cam does stuff like that.
Bro, why you like this, bro?
Oh, you said Jaden?
I do.
Oh, my fault.
Oh, you said Cameron? Oh,
I say you.
He more concerned about the whooping I'm finna give him the dad crap.
I'm not I'll sting you.
Y'all.
Okay, so now we're developing, okay, so we kind of know how to find imaginary solutions when they're not real. Well, now in groups, how do you want to do this? You want to do 2 or 3?
We did it right here, I mean.
Oh, I'm 3.
2 or 3?
Now, I mean,
2 or 3.
I'm gonna pull Jail over here to talk to her for a second, so let's go ahead and go 2 groups. Because
Okay.
I believe I already asked you to be in group 1, and I let you get away up to this point not being in group 1.
Yeah, we got about 20 minutes left.
Alright, so move on up for the last 20 minutes.
Okay, yeah, so for the last 20 minutes,
hey,
guys,
brother, I don't be coming.
we're gonna, y'all, the last 20 minutes we're sorting cards, like, we're not doing anything like mentally
No.
demanding. But also, look who helped us cut out the pretty cards and
The
put the
dog.
little baggies.
The
Yeah.
dog,
Miss Molly helped us.
Miss Molly, that's your dog name?
just seeing them.
Dude, Jayla, what did you talk about?
Okay, so think about, these are your directions. Out of these all these other cards, look at them and separate them and say, how can we split this up into different kinds of groups?
Hey, you ain't got
Oh.
no
Oh,
So control
I'll
is
get
a
action
Huh?
I'll get action.
you said it.
No, it ain't me. You being ashy like my
Like your tattoos?
You got some oil at.
You got some petroleum jelly?
Okay, wait, let me finish these directions, guys. So look, you're gonna split them into groups and then you decide why you're splitting them into those groups.
Get it.
Hey.
Yeah, toss ride.
And you're gonna decide why you split into those groups. So when you're doing this, think about what kind of numerical groups have you talked about in math before? Like what types of numbers do you guys know?
Real numbers.
Real numbers.
Yeah, you can.
Okay, what else? Not variables. What about like whole numbers? Or think about how there's different kinds of decimals and how those can be classified to be different things. So
I'm the guy.
golly.
Like Uno.
I'm thinking about 10 colors, about 100.
I think there's like 30.
30.
But-
30 bowl.
The whole point is like you can group these in different ways depending on what rule you establish for that
Hey,
group.
do what we do. You know, so that they're like this, because you don't need one.
Up to you. So yeah, there's no, I don't have an answer. There's no like, right now, at this moment, there's no right or wrong for this. You're kind of making your own rules for your groups and deciding. Because part of it's like, let's say we group like this to get,
So what you doing? I'm trying to.
okay, so like let's say if we want to group this, like what's another card we might want to group this number with?
With the number right there.
Okay, so why do you group these two together?
They real.
They're both whole numbers, okay? Aren't there whole numbers on here I can put in this group?
Dude, okay, but.
Why'd you say that one, Ryan?
I forgot. Cause, I.
Not just the I, but what's the raising it to a 0 power do?
Yeah, 0.
What does raising anything to a 0 power do? It is not equal to 0, do not put it down.
No,
What's anything raised to the 0 power? It's like, oh my gosh, you have
I
calculators.
said 0.
It's not 0. It's not 0. Raise it.
Oh, is this so?
No, no it's not.
How?
So that would be, okay, so.
What is 2 to the 0?
2.
It ain't 2.
It's 0.
It ain't 0.
It is 0.
No, it's not.
It's 2.
No, it's not.
It's 1, so it's
It's-
equal to 1.
Oh, yeah.
Oh, yeah.
So anything raised to the 0 is,
Listen to me, son.
So they basically matching. So
Yeah,
how you
it's, yeah, like grouping. Okay, so, okay. Oh, but wait. What would this like be equal to?
Too late.
You know what this is?
You don't know that one?
Mistake. What?
You know what this is?
Oh.
Ah! in that group too? Okay.
Okay.
Well, then that's a rule you can define for that group.
My headline would be, watching my food.
Okay, maybe it might be better for you guys. Let me just show you. Let me show you.
I think,
This is where we're going with this. We're going. Okay, sit. Sit.
oh yeah, full of bacon, right?
I'm sorry.
I went on.
Do you forgive me?
What?
Hot, dude.
Okay,
Is it white?
this is the complex number system. Okay, this is the complex number system. So essentially, think about how could these cards fit into these different categories. So like, what makes whole numbers different from natural numbers?
Whole
You
numbers.
say natural, you say natural.
Well, what are natural numbers?
Like,
Real.
Well, these are real
well, whole
numbers.
numbers.
They're all
real,
under real
Whole
numbers.
numbers real, ain't it?
Whole number.
Yeah, whole numbers are real numbers, and so are natural numbers. But wait, we're not
know
two.
this.
So when we're talking about natural numbers, remember, that's just like, you can think of that as like your counting numbers. So like, what number do you naturally start counting at?
1, 2, 3, 4, 5, 6, 7.
Right, so that's like 1, 2,
3.
okay, well, what's different about whole numbers?
Like, and then like go by.
They not the decimal.
That's it, starts at zero, starts at zero. It's the same, but
I was just
starts,
Like 0, 1, 2, 3, 4, 5, 6.
okay? Now, what about, well, how are integers different from
And then
whole
like,
numbers?
and then like even the odd number. No.
Not even an odd, but
Odd numbers.
Positive.
Positive.
this is including all of our whole numbers, but also includes negatives.
Yeah, good duck.
Okay, so wait, so now that you guys know how this little number system is set up, can you see how some of these cards, like originally you might say, where's the card? So originally you might say, oh, this is a
What?
whole number,
Yeah, this
but
whole number.
isn't this also an integer?
Yeah.
Okay, so but is this rational?
Can it be what else can I get about natural? Natural number?
Well, right. So remember, the way this is set up, it's saying that all natural numbers are whole numbers, all whole numbers are integers, all integers are rational numbers, but not going. That doesn't necessarily mean the same thing going backwards. Because what's a whole number that's not a natural number?
0.
Okay, so we can go one way, but not always the reverse way. Okay, so we're talking about, we're still trying to classify these numbers, so, which I guess I want to, oh wait, what's today, Friday? Thursday? So tomorrow, okay, so tomorrow I guess what we'll be doing is actually sorting these into those groups, but still start thinking about how they can be classified differently.
I seen pie when I was really.
Okay, so, well, what kind of number is pi?
It's like real. No.
It's a rational.
Do that.
Pi is an irrational number. So pi would be, is pi a real number?
Yes.
Okay, so look, all real numbers are either going to be rational or irrational.
And
Okay, so pi, it just stops there. But if you have a real number, such as, so like, what about 2 divided by 5? That's a card y'all have. Where would I put
right
this,
up there.
this value?
What it is?
What does that equal as a decimal?
40.
What it be?
So that's 0.4. Okay, well, is that an integer?
No.
No. Well, is it a whole number?
Not natural number. I think it's natural.
Yes.
What it be
Well,
natural?
remember, what do our natural numbers include decimals?
No.
Do our whole numbers include decimals?
No.
Do the integers include
No.
decimals?
Real number.
What about rational numbers?
Yeah.
So what do you guys know about rational numbers?
They're gonna know,
It
like,
includes decimals, but
decimal, y'all.
how else can they be written?
Fraction.
Percentages.
Fractions.
Oh, fractions. You understand?
So rational numbers can also be written as fractions, which would make this 2/5 a rational number. Would also be a real number. Would it also be a complex number?
Sure.
Okay, and we're not defining complex numbers today, but we'll learn about more about that tomorrow. But looking at these cards, so let's talk about, what about these two?
1/3.
Yeah, go ahead.
Okay, so you have the square root of negative 400 and negative square root 400. What's different about those two?
Negative on the outside.
One on negative. And
So
one
how is that going to change where it falls in this organizer?
If you give the square root of a negative number.
One of them gonna be negative and
Okay,
one
if
of
I-
them only gonna have a negative answer.
One of them be imaginary.
So one's going to be imaginary because I'm taking the square root of this negative,
Facts.
right? What would this one be equal to? Since my negative's on the outside, does it make it imaginary?
Never. One to be
Negative 20, huh?
Yeah.
what's the name?
So you see that, Cam?
Mm-hmm. Want you to avoid.
I can tell. So, how would we classify this card?
Imaginary.
Okay, and then how would we classify this card?
Negative. Integer.
Those are written.
Right, integers, so it is a real number. What? Okay, let's talk about the different kinds of decimals. What do you want?
She's teaching.
So talking about the different kinds of decimals, we have repeating decimals, terminating decimals, and non-terminating decimals.
Alright.
So what does it mean if a decimal's repeating? Give me an example.
Alright.
No, that's not a decimal.
33%.
0.4 with the.
That's a
A
percent.
third.
That's a fraction.
Which one you
0.4
need?
with the negative.
Okay, 0.4 with a line at the top to show. I want you to give me the decimal, Cam. I know that 1/3 equals point, but I want you to tell me that 0.333 because we're looking at. So this could be like that, but also if you saw it like that, it's repeating. So remember, repeating decimals, can they be written as fractions? So that would make them, would that make them rational or irrational? Okay, so remember if we can write it like a fraction, rational. And we also